When people first started exploring space in the 1960s, it cost upwards of $80,000, adjusted for inflation, to put a single pound of payload into low Earth orbit. A major reason for this high cost was the need to build a new, expensive rocket for every launch. That really started to change when SpaceX began making cheap, reusable rockets, and today the company is ferrying customer payloads to LEO at a price of just $100 and $300 per pound. This is making space accessible to scientists, startups, and tourists who never could have afforded it previously. But the cheapest way to reach orbit might not be a rocket at all. It could be an elevator. The space elevator. The seeds for a space elevator were first planted by Russian scientist Konstantin Tsiolkovsky in 1895, who, after visiting the 1,000-foot 305 meters Eiffel Tower, published a paper theorizing about the construction of a structure 22,000 miles, 400 kilometers high. This would provide access to geostationary orbit, an altitude where objects appear to remain fixed above Earth's surface. But Tsiolkovsky conceded that no material could support the weight of such a tower. A space elevator could bring the cost of sending a payload to any Earth orbit as low as $100 per pound. In 1959, soon after Sputnik, Russian engineer Yuri N. Artsutanov proposed a way around this issue. Instead of building a space elevator from the ground up, start at the top. More specifically, he suggested placing a satellite in geostationary orbit and dropping a tether from it down to Earth's equator. As the tether descended, the satellite would ascend. Once attached to Earth's surface, the tether would be kept taut thanks to a combination of gravitational and centrifugal forces. We could then send electrically powered climber vehicles up and down the tether to deliver payloads to any Earth orbit. According to physicist Bradley Edwards, who researched the concept for NASA about 20 years ago, it'd cost $10 billion and take 15 years to build a space elevator, but once operational, the cost of sending a payload to any Earth orbit could be as low as $100 per pound. Once you reduce the cost to almost a FedEx kind of level, it opens the doors to lots of people, lots of countries, and lots of companies to get involved in space, Edwards told Space.com in 2005. In addition to the economic advantages, a space elevator would also be cleaner than using rockets. There'd be no burning of fuel, no harmful greenhouse emissions, and the new transport system wouldn't contribute to the problem of space junk to the same degree that expendable rockets do. So, why don't we have one yet? Tether troubles Edwards wrote in his report for NASA that all of the technology needed to build a space elevator already existed, except the material needed to build the tether, which needs to be light but also strong enough to withstand all the huge forces acting upon it. The good news, according to the report, was that the perfect material, ultra-strong, ultra-tiny nanotubes of carbon, would be available in just 2 years. Steel is not strong enough, neither is Kevlar, carbon fiber, spider silk, or any other material other than carbon nanotubes, wrote Edwards. Fortunately for us, carbon nanotube research is extremely hot right now, and it is progressing quickly to commercial production. Unfortunately, he misjudged how hard it would be to synthesize carbon nanotubes. To date, no one has been able to grow one longer than 21 inches, 53 centimeters. Further research into the material revealed that it tends to fray under extreme stress too, meaning even if we could manufacture carbon nanotubes at the lengths needed, they'd be at risk of snapping, not only destroying the space elevator but threatening lives on Earth. Looking ahead, carbon nanotubes might have been the early frontrunner as the tether material for space elevators, but there are other options, including graphene, an essentially two-dimensional form of carbon that is already easier to scale up than nanotubes, though still not easy. Contrary to Edwards' report, Johns Hopkins University researchers Sean Sun and Dan Popescu say Kevlar fibers could work. We would just need to constantly repair the tether, the same way the human body constantly repairs its tendons. Using sensors and artificially intelligent software, it would be possible to model the whole tether mathematically so as to predict when, where, and how the fibers would break, the researchers wrote in Aeon in 2018. When they did, speedy robotic climbers patrolling up and down the tether would replace them, adjusting the rate of maintenance and repair as needed, mimicking the sensitivity of biological processes, they continued. It could be built from fibers that are already mass-produced and relatively affordable. Astronomers from the University of Cambridge and Columbia University also think Kevlar could work for a space elevator, if we built it from the moon rather than Earth. They call their concept the space line. And the idea is that a tether attached to the moon's surface could extend toward Earth's geostationary orbit, held taut by the pull of our planet's gravity. We could then use rockets to deliver payloads, and potentially people, to solar-powered climber robots positioned at the end of this 200,000-plus mile-long tether. The bots could then travel up the line to the moon's surface. This wouldn't eliminate the need for rockets to get into Earth's orbit, but it would be a cheaper way to get to the moon. The forces acting on a lunar space elevator wouldn't be as strong as one extending from Earth's surface either, according to the researchers, opening up more options for tether materials. The necessary strength of the material is much lower than an Earth-based elevator, and thus it could be built from fibers that are already mass-produced and relatively affordable, they wrote in a paper shared on the preprint server Archive. China predicts its Sky Ladder could cut the cost of sending people and goods to the moon by 96%. Some Chinese researchers, meanwhile, aren't giving up on the idea of using carbon nanotubes for a space elevator. In 2018, a team from Tsinghua University revealed that they'd developed nanotubes that they say are strong enough for a tether. The researchers are still working on the issue of scaling up production, but in 2021, state-owned news outlet Xinhua released a video depicting an in-development concept called Sky Ladder that would consist of space elevators above Earth and the moon. After riding up the Earth-based space elevator, a capsule would fly to a space station attached to the Yajirobi, tether of the moon-based one. If the project could be pulled off, a huge if, China predicts Sky Ladder could cut the cost of sending people and goods to the moon by 96%. The bottom line. In the 120 years since Tsiolkovsky looked at the Eiffel Tower and thought way bigger, tremendous progress has been made developing materials with the properties needed for a space elevator. At this point, it seems likely we could one day have a material that can be manufactured at the scale needed for a tether. But by the time that happens, the need for a space elevator may have evaporated. Several aerospace companies are making progress with their own reusable rockets, and as those join the market with SpaceX, competition could cause launch prices to fall further. California startup Spin Launch, meanwhile, is developing a massive centrifuge to fling payloads into space where much smaller rockets can propel them into orbit. If the company succeeds, another one of those big ifs, it says the system would slash the amount of fuel needed to reach orbit by 70%. Even if Spin Launch doesn't get off the ground, several groups are developing environmentally friendly rocket fuels that produce far fewer, or no, harmful emissions. More work is needed to efficiently scale up their production, but overcoming that hurdle will likely be far easier than building a 22,000-mile, 35,400 km elevator to space.